Hello. So now we'll be solving question number 26 from phase 1, chapter called Forces and the Laws of Motion. It's in the exercise 1. It's a pretty nice question. Let's see it. A cyclist is riding with a speed of 27 km per hour. So first thing first, basically, we need to convert this kilometer per hour into the meter per second. So the speed of the cyclist is 27 kilometer per hour, and I can convert this in terms of meter per second. So 27. So how to convert it? This kilometer you convert into the meters. So 1000 meters divided by hours you convert into the second. So 60 into 60 second. So I converted the kilometer into meter and I converted the hour into the second. This velocity will be 15 by 2 meter per second. This is the velocity. So riding with a speed, as he approaches a circular turn, if he is approaching the circular turn, so obviously this velocity will be along the circle, which is tangential velocity. If a cyclist is moving onto a circle, the velocity will be along the tangent. So this is the tangential velocity, speed basically. The radius of that circular turn is given as 80 meters. The radius is given as T meters. He applies brakes and reduces the speed at a constant rate of 0.5 meter per second. Find the magnitude of the net acceleration. In this question, the key aspect is net acceleration. So we all know, like when it comes to circular motion, in case of circular motion, the net acceleration we divide into two components. The net acceleration we divide into two components. One is centripetal acceleration and the second is tangential acceleration. This centripetal acceleration is responsible for changing direction, and this tangential acceleration is responsible for changing speed. This is changing speed. And both of these accelerations, they are components basically. They are mutually perpendicular. The net acceleration comes out to be under root of AC square plus AT square. So whenever it's circular motion, we calculate both the accelerations separately to calculate the net. So let's first calculate the AC. The centripetal acceleration, the formula is Vt square by R. As you can see, the Vt is also given and the R is also given. So we got the value of AC. The main part is AT. As you can see, they are saying he applies brakes and the reduces his speed. His speed. And the acceleration component, which is responsible for changing speed, is AT. So if this speed is reducing, it is due to the AT, tangential component of acceleration. And the speed is reducing with a constant rate of 0.5 meter per second. So AT basically you can say delta Vt upon delta T. Change tangential speed divided by time. So the change in speed, they are saying 0.5 meter per second in 1 second. So divide by 1 second. So you get 0.5 meter per second square. That's your AT. That's the critical part because they have given in terms of language. So once you get the AT and you already have the AC, these values you'll be putting in this equation to calculate the net acceleration. And the net acceleration, when you will calculate from this formula, it will be coming out to be 0.86 meter per second square. Okay. It's a pretty nice question because the thing is, it involves this component. Okay. Thank you.